Good morning, class, or afternoon, or evening. Today we are going to do a quick summary of the three forms of the quadratic function which we have talked about individually as lessons, and then we did a nice foldable, and this is just another way to put everything on one page. So, from standard form, what's the easiest thing that we can see?
Well, the easiest thing is, of course, the y-intercept. Because y-intercepts happen when x is 0, and if you were to substitute 0 for x, the first two terms will go away, and you will have c left. So 0 comma c will be your y-intercept.
Good. And the axis of symmetry, do you have to memorize that formula?
This formula will be given to you.
I get a lot of students who have trouble with that vertex. What's actually going on there? So the axis of symmetry they can calculate, and then they have trouble understanding what that notation's telling them. But let's simplify it for them. What are they actually doing with those numbers?
So the axis of symmetry, the equation you get, this x value you get is the x coordinate of the vertex. So this number here and this number here will be the same. And in order to find the y value when x is negative b over 2a, you would substitute whatever this number is back into the original function and get the y value. And that's what this notation is, f of negative b over 2a.
Excellent. Then in the x-intercepts, we basically spent the whole last unit quadratic algebra working on ways to solve equations set to 0, which is finding the x-intercepts. So if it doesn't factorize, then you can use the quadratic formula. I think that's all about that form.
Yeah.
Factored form. What's the easiest thing that we can see with the factored form?
The easiest thing would be the x-intercepts.
I get real hung up on putting these as coordinates. What about you?
Yeah, they keep putting x equals 2 and x equals 5.
It's from the solutions, isn't it?
Right.
But what we're after with the x-intercepts, we prefer to see it as coordinates. Good. And halfway between the coordinates of the x-intercepts, by the symmetry, what do we end up with?
We get the axis of symmetry.
Good. And then we got that funny notation again, which really just tells us
Whatever you have for the x value of the axis of symmetry, you substitute that value back in the function and you get the y value, and that is a y coordinate of the vertex.
perfect. And finally, we talked about vertex form. And with vertex form, there are two things which are super easy to find, and they are
The axis of symmetry and the vertex.
good. And every once in a while, students make a little bit of a sign mistake with the minus h, but think about that transformation. Think about that as a transformation sometimes helps. Good. And when you're finding the x-intercepts from vertex form, some students like to expand it out to standard form and use the last unit's knowledge about quadratic algebra. Other students, probably more efficiently, will just use inverse operations to solve and unwrap that x there.
And if you actually set this y value equal to 0 and solve, you are less likely to come up with a bigger number inside the surd, and so you don't have to simplify more often than not.
That's a good tip. Good. All right, so let's try it with some numbers, and then you should be confident. So let's start with what's easiest. From standard form, we can easily see the y-intercept, so we'll write that in. Okay, what's the next thing we usually tackle?
That would be the axis of symmetry.
So from the formula booklet, x equals minus b over 2a. And now it gets a little bit sticky. We might need a little bit more space, but we're going to replace x with 3/4 and solve for y, or the output. Let's see how good Mr. Song is with fractions.
Ooh. Okay, that would be 9/18 over 16, or 9/8.
Simplified all at once. Well done.
9/4 minus 2. That will be
Common denominator of 8.
yeah, negative 8 minus negative 9/8 minus 16/8. That would be negative 25/8.
Okay, so putting it together, we've got a nice value of the vertex. And x-intercept.
Let's see, I think that's factorable. So
Let's go back and use our knowledge of quadratic algebra. What numbers are going to match up here?
Okay, that's going to be -4, and that's going to be +1.
Mm-hmm.
So it'll be 2x minus 1 and x plus 2. Let's check. That's going to be 4x. Uh-oh.
Signs wrong way. That's nice about checking, though. You can usually get it pretty quick. Okay.
There. And I think now I'm right.
Mm-hmm.
So then the x values will be 2 and -1/2. So I'll write it as 2, 0 and -1/2, 0.
Perfect. All right, from factored form, what can we easily see from the factored form?
Well, we just factorized this standard form to find the x-intercepts. Of course, the x-intercept will be the easiest thing to find there.
Mm-hmm.
And that would be 2, 0 and -4, 0.
Super. I like things that are easy. And I guess it doesn't really matter which way we want to go next.
Mm-hmm. But I'll go with the axis of symmetry first.
Mm-hmm.
So axis of symmetry, as the name suggests, it's in the middle of the parabola, and so it's going to be right between the two x-intercepts. So I'm going to add the x-intercepts and divide by 2. It'll be the same thing as finding the midpoint.
Mm-hmm.
So x equals -1 is your axis of symmetry.
And from the exit slips, we're seeing some students just put -1. Remember, the axis of symmetry needs to be in an equation form. Now we substitute that in and solve for the y value of the vertex.
It would be -27, so the vertex is at -1, -27.
Mm-hmm. And the y-intercept?
The y-intercepts happen when x value is 0. So we are substituting 0 for x. So f of 0, 3 times 0 minus 2, and 0 plus 4. That's 3 times -2 times 4, and -24.
Okay, so 0, -24 is the y-intercept. Again, coordinates for intercepts and vertex, an equation for axis of symmetry.
Okay. The last one is the vertex form. And of course, the easiest thing to find is the axis of symmetry and the vertex. Axis of symmetry would be x equals h, and the vertex would be h comma k.
Perfect. And then x-intercepts, let's use your strategy because I think that's the most efficient.
Mm-hmm.
I would encourage students to use that as a strategy.
So I'm replacing the y with 0, so and solving for it, for x.
X minus 1 squared.
Aha.
And as you're working this, rather than expanding, I would encourage you to use inverse operations. Add that 9 to both sides.
And here's the part that you have to remember. When you take a square root of both sides, you have to add the plus or minus.
You get two solutions. There are two numbers, a negative and a positive number, which when you square them, right, two values of x which are possible. And those would be excellent.
So you get 4, 0 and -2, 0.
Perfect. And finally, y-intercept, not
Y-intercept.
too hard. A little bit of evaluating, but easy enough. Substitute in x equals 0, and we end up with, well, a giant eraser that time, eh?
Upgrading. 0 minus 1 squared minus 9. And this is -1 squared. So that'd be 1 minus 9 is -8.
Excellent. There's one thing from the exit slips that I want to pick up on that I don't know how your students are doing, but mine are having a bit of difficulty with range. Domain they're doing all right with, but range. What do you focus on? Maybe we could put another column here and or just put some ranges at the end.
Mm-hmm.
When you're doing the range, what two things do you concentrate on?
Well, we need to look at the a value of the function,
Mm-hmm. That determines,
to whether the parabola is opening up or down.
and it's stretched. Good, okay. All three of these end up opening up.
Right. And then the y value of the vertex, because this is either the highest point or the lowest point of the parabola.
Mm-hmm.
There. So it's the parabola is opening up in this example, and the lowest point for the y value is negative 25 over 8. So your range would be y is greater than or equal to negative 25 over 8.
Okay, good. So let's stop there and remember the different forms give you some things quite easily and some things with a bit more work. And the vertex, the y value of the vertex, is very useful in combination with the vertical stretch or reflection to determine what your range is. Anything else?
Nope, that's it.